In this lesson, we're going to explore solving equations with flowcharts, which is a topic you may not have seen before. It turns out that using flowcharts is a way to design a roadmap for ourselves for solving equations. Why would we ask students to do this, especially if you're already comfortable with solving? Well, solving with flowcharts will help you to build confidence. It's going to help make clear the links between solving and our order of operations. And it also reinforces patterns in solving that are used with the traditional method. Not only that, but almost all of our students find that once in a while they come across equations to solve that would be very difficult with the traditional approach and much friendlier to use solving with flowcharts. So when we talk about solving, solving means finding the value of the unknown that makes the statement true or makes the equation true. Another way to think about solving is that solving is breaking down the equation by unbuilding it. If you've watched the lesson on the order of operations, you've seen the reference to building already. So if you can correctly show how an equation was built, you can also show how to take that equation apart to solve it. Keep in mind, our equations were built following the order of operations. So solving, we're going to follow the reverse order of operations. So let's take a look at this equation. 5n adding 11 is equal to 41. To build this equation, we start with n. In my equation, I see multiplication and adding. The order of operations tells us that multiplying by 5 would happen first, so we build our 5n, and then we build in the addition. This 5n added to 11 is equal to 41. In order to solve, we're going to work our way back up the flowchart, undoing each stage. So to undo adding 11, we'll subtract 11. 41 subtracting 11 gives us 30. To undo multiplying by 5, we're going to divide by 5. Now we've reached the stage where we were talking about our single n, and it turns out that that single n is equal to 6. Let's take a look at another example. In this example, we have 100 subtracting 4x, and all of that is divided by 11, giving us a value of 5. This is a good time to think about our invisible brackets again, and a good time to draw them in. So thinking of our invisible brackets, we can see that we're going to have to build 100 subtracting 4x first. We start with x. We have to decide if that subtracting 4x represents positive 4x or negative 4x. And it may be helpful here to put an addition symbol or a positive symbol in front of the 100. This is positive 100 and negative 4x. So we're going to take that x and multiply it by a negative 4. And then to give us positive 100, we're going to add 100. And lastly, we take that entire expression and divide by 11. All of this is equal to 5. Working back up our flowchart to undo dividing by 11, we multiply by 11. 5 multiplied by 11 gives us 55. To undo adding 100, we subtract 100. 55 subtracting 100 gives us negative 45. And to undo multiplying by negative 4, we divide by negative 4. Now we're going to be careful here. This is a negative divided by a negative, and from our review of integers, we know that the result is going to be positive. In this case, positive 11 and 1/4. And there's no reason to think that a decimal number is a poor answer or a wrong answer in Math 10. Sometimes that's the way things work out. If you're ever not confident, you could try putting that value back into the equation for x and seeing if both sides work out to be equal to 5. Let's take a look at another example. Something like this is an equation that would very often make students feel a little uncomfortable, but using our flowchart strategy, we find out it's not actually so bad to solve. We're going to start with p and multiply by 3, subtract the 5 to build everything that's inside the brackets, multiply by 2, and now we put on our cube root symbol. All of this is equal to 2. Working back up our flowchart, the opposite of cube root is cubing. 2 multiplied by 2 multiplied by 2, which is equal to 8. The opposite of multiplying by 2 is dividing by 2. The opposite of subtracting 5 is adding 5. The opposite of multiplying by 3 is dividing 3. Without too much trouble, we find out that in this equation, p must be equal to 3. Unfortunately, the flowchart method doesn't work if we can't build a correct flowchart to represent how the equation was made. Here's an example where a flowchart wouldn't work. Can you see why? It turns out the variable is in 2 places. If we see our variable in more than one place, that's a sign for us that we can't solve with a flowchart. However, so long as the variable is only in one place, we could look at an equation like this that looks very, very complicated, use a flowchart to show how it's built, and use that flowchart to correctly solve. Keeping in mind, the end goal with flowcharts is not to use this as your strategy for the entire course, but to improve your algebraic thinking and solving skills, and to give you a strategy to use if you get really stuck.